Welcome to the Profile Corner. In today's video we'll be talking about radial arm saws. Radial arm saws have some unique capabilities that you cannot find in other types of saws, including sliding compound miter saws. And so we'll be looking at some of those capabilities today. I have the camera pointed right now at a Delta 12-inch 33-892 saw. This is a 3-phase saw, and it has 1.5 horsepower. We'll talk more about the capabilities of this specific saw, which is a turret style, in a couple minutes here. Let's talk about some more general things about radial arm saws. I have 4 saws in my shop right now, and I'll be showing you those later in the video, but we'll start out with this saw. Okay, this saw has a 12-inch blade mounted in it. This is another blade that's also 12 inches. And the neat thing about radial arm saws is that the workpiece does not move. It sits still on the table surface when you're using the radial arm saw safely. Now, when I say safely, I mean that you're not using it for doing rip cuts. I don't recommend using a radial arm saw for doing rip cuts. Only crosscuts and miters and bevel cuts should be attempted on the radial arm saw so that the workpiece is never moving on the surface of the table. And that makes the saw extremely safe. This is, once again, an example of a radial arm saw blade that could be mounted in the saw. As a matter of fact, this was the blade that was installed in the saw when I bought this saw from a manufacturing facility that was using it in production back in the early 2000s. So this is a high tooth blade, but this is the wrong type of blade actually to be used in a radial arm saw. We'll talk more about that in just a minute. One of the things that you can do with a radial arm saw, obviously, is to have the blade come out 90 degrees to the table surface, just as this one is coming out right now. And you can also have it tilted at a bevel, so instead of coming out straight up and down like this one, you can have it tilted at a bevel if you need to make those types of cuts. That's not a problem. You can also have it come out at an angle like that, at a miter angle. That's an easy function of the saw. In addition to that, you're also able to fully turn the saw blade 90 degrees like that. You would be able to do rip cuts on the radial arm saw. But once again, I do not feel that that's a safe operation on these saws. It's much safer to do those style cuts on a table saw. In addition to being able to have the saw blade 90 degrees and at bevels and at miters, you can also essentially rotate this whole assembly downward, and so the saw blade could actually be sitting down on the surface of the table just like this. Dusty Lumber Company has shown several radial arm saw videos where he's used the saw blade in this orientation when he's cutting various types of joints, such as mortise and tenon joints. And in addition, many radial arm saws are also able to tilt the motor the opposite direction so that the saw blade would essentially be up here, and they've got an auxiliary shaft on the other end of the motor that would then allow you to power other types of tooling. I wouldn't recommend doing that, such as shaper heads or something like that. That's just a little bit too dangerous in my mind for a radial arm saw. This saw excels at doing straight 90-degree cross cuts, miter cuts, and also bevel cuts on boards. And with a very good saw like this one here, the turret style Delta 12-inch, you're able to achieve the same precision that you can get at a table saw, or even beat that precision that you get at a table saw. This saw, compared to a compound miter saw or a sliding compound miter saw, there's essentially no match. This saw, you simply cannot deflect it. I can try to push on this handle as much as possible, and this blade is not moving at all down at the bottom. I tried that out with essentially a new Bosch sliding compound miter saw. It was a 12-inch saw, and I just tried to move it ever so slightly using the handle, and I was able to get that blade to move 3/16 of an inch from side to side. With that kind of slop, you cannot get any kind of precision out of those types of saws, and that's one of the big disadvantages of a sliding compound miter saw compared with a radial arm saw. Sure, they're much more compact than a radial arm saw, but you don't get the same level of precision. They'd be fine for rough cuts, which the radial arm saw also excels at, but for fine cuts, you should look for a different type of a saw. My DeWalt compound miter saw is reasonably accurate. I can probably get a little bit of deflection out of it if I were to try to wrench on the handle, but nowhere near what I was getting out of that Bosch sliding compound miter saw that I saw at an auction. I'll put a picture of that saw on the screen so that you're able to see what it looked like at the auction. It was in perfect shape. What's wrong with this saw blade? This is the saw blade that came on the saw. It's a 72 tooth blade, so that sounds like that should be a good crosscut saw blade. It is a very good crosscut saw blade for a table saw, if you have a 12-inch capable table saw. The problem with this blade is that the teeth are at the wrong angle. If we put this board across the center line of the blade and look at the teeth, if I can get it into position there, if you look at this tooth here, it has a positive hook angle. In other words, angled toward the board that's going to get cut. Radial arm saws tend to be rather grabby because they're always climb cutting. That means that they're always trying to self-feed themselves through a board. And so with a positive tooth angle on your saw blade, it's going to try to do that quite significantly when you're trying to control the crosscut. And so this is the wrong style blade. Instead, what you'd want is what I've got on here. This is a Forest Chopmaster blade. These are kind of expensive. It has a -5-degree hook angle, which means that instead of the teeth angling toward the board that's getting cut, as is the case here, it actually tips backwards away from the board that's getting cut, which means that it's going to make a less aggressive cut. And so that means that this saw is not going to try to self-feed itself out as you're trying to make a cut. So it makes the radial arm saw much safer. In addition to that, these 12-inch radial arm saws tend to be much less likely to self-feed than a 10-inch or a 9-inch radial arm saw. And that's because the tooth angle here tends to put more of the downward force onto the table rather than generating a backward force back to the fence here, which would then propel the blade moving forward. And so the 12-inch saws tend to be safer to use than a 10-inch saw. When you're using a radial arm saw, you need to be very careful in terms of how you stand. Okay, so the correct posture for using a radial arm saw is to keep a stiff arm. In other words, when you're pulling this out, don't stand real close to the saw and pull it toward yourself, because if the saw blade snags on a hard part of the board, such as a knot, or it gets bound up, this saw blade is going to try to run forward at you. Especially if you've got the wrong style blade mounted onto the saw. And so what you want to do instead is to have a posture where you're keeping your arm stiff, and so you're pulling it toward yourself, just like so, while you're also pushing it away from yourself whenever necessary to keep that saw under control. So in other words, you can pull it out like this, keep yourself with a stiff arm, and it comes out in a nice controlled fashion. Okay, so let's cut a board on here. I've got a rough sawn black walnut board. I'll need to flip on the 3-phase converter that I have so that I can turn on the saw. Give me just a moment to grab that board that we can cut. Okay, I have the 3-phase converter running, and I have the piece of black walnut mounted up on the table. And what I need to do is look at this board and decide how I want to have it cut. I have, let's see. This end looks like it's been cleaned up. The other end here looks like it has some checks in it. So why don't I take that end off, and I'll put this up onto the table. And what I want to do is I want to watch here where this board meets the fence. I need to hold on to this board and make a cut. However, we've got some small issues here in that there's a slight gap right back here at the fence. And if I were to hold this board against the fence, what's going to happen is that as this saw makes it way all the way through the board, as soon as it gets out to here, this board that's away from the fence is going to try to push itself against the fence, and that'll cause a binding problem with the saw blade. And so we want to avoid that. So what I'm going to try to do is flip this over and see if we're in better shape. Okay, this board is quite warped in this direction, which could be a problem for us. Okay, so that's going to be a problem if we try to cut it that way, because it's going to want to rock on the table, and that's not safe either. So let's try it this way again. Okay, so if we try to do it this way here, we're going to have a little bit of a gap. So what I want to do is I want to stick something down into that little bit of a gap so that this board cannot go any further back. As a matter of fact, I probably don't have to do that because the piece that I want to cut off is right here at the end, and it looks like there's a significant curvature in the board. And because I've got a very long fence on this saw, I'm able to capture a high point here and also out here at the end, and so I'm not going to have an issue. However, I'm right-handed, and so we've got an issue. I can't hold this small piece with my left hand and pull the saw out with my right hand, because that puts my thumb into the danger zone where it could be cut. So what I'm going to have to do instead is to hold this board down using my right hand, and then I'll pull the saw out using my left hand. My right hand is my dominant hand, but in this case I'll have to use my left hand to pull the saw out. Okay, so let's try to make this cut and see what happens. Once again, I've got support right here against the fence and also at the opposite end, and that's very important. It's also important that the board doesn't rock like this on your table. So let's see what happens if we try to make this cut. Okay, that was a really easy cut. And as a matter of fact, I moved the saw through much slower than I actually had to. Because what I was trying to do is to achieve a very nice cut. If I hold this board up, you can see that there's no chip out on the back edge or anywhere here in the cut. It's all very clean, and that is in large part due to this Forest Chopmaster blade, and also because I have a zero clearance fence right here. In other words, this gap is exactly as wide as the blade is, and so is the kerf that's down here at the bottom. Now, unfortunately, the people that worked at the company that owned this saw before me, they made a large gap down here in the table, and so that's a little bit of a problem. But other than that, this table surface is like new. They never use this saw at any angle other than 90 degrees for the bevel and also for the miter cut. Otherwise, this table surface would be all chopped up. And so what you would want to do is, if you've got a new saw or a saw that is in decent shape, you would want to put a sacrificial 1/4 inch MDF top onto this, and that'll give you a nice clean surface for all of your cuts, so that you can have zero clearance underside on the board also, so that you get a clean cut. The manual for the 10-inch Delta professional saw that I have recommends using that 1/4 inch MDF on top of the table surface. I didn't see that recommendation in the manual for this saw, but it is definitely recommended. Okay, so we have some decay here in the end of the board. I want to take a little more of that off. Let's see if we can put this back onto the table. Okay, so that's the wrong way because it rocks. So let's try it this way. Okay, now I still have an area here that's supported at the fence. If I were to bring this over further, such as right there, there's now a gap at the fence, so I couldn't cut it off there without first putting in a shim into this area of the fence to make sure that it's safe to cut. So let's make another cut here, and I'm going to take a little bit more off the board, and this time I'll move the saw out a little more rapidly, once again using my left hand to control the saw. And you got to keep an eye on where that blade is at all times. Okay, that was a more typical speed to move the saw blade through the cut. Let's take a look at the quality of the cut. It still looks pretty much perfect, and that's because of the blade I have installed on this saw. You want to make sure that you don't shortchange yourself with saw blades for radial arm saws. You need one with a negative hook angle and also quite a few teeth. And the Forest Chopmaster blade satisfies that, although this particular blade I believe was right around $235 or so when I picked it up about 1.5 years ago. And the reason why I'm here at the radial arm saw is because one of the steps that you've got to look at is, do you have any odd crooks in your wood that'll cause problems at the joiner? In other words, do you have any problems where there's a really odd cup, and in order to remove that odd cup from the wood, you'd end up making the board way too thin? So you could look at your plan for the wood and decide, okay, well, I can cut it at this point here and use that portion of the wood and this portion of the wood to eliminate a significant twist in the board. And then once it goes over the jointer, then you're not losing nearly as much wood. Another thing that you can look at here is that I've got a significant defect down on this end. I've got a split here, and I've got a large knot. And it's not going to make much sense for me to joint this section of the board and then plane this section of the board. It'll just be wasteful. So at the radial arm saw, I can just chop that off, and then I don't have to worry about it. Now, if you don't have a radial arm saw, you can use a chop saw potentially, or some other saw, maybe a sliding compound miter saw, a track saw, a handheld circular saw, or something like that. You do need to make sure that you've got this pushed tightly up against the fence, and that after the cut takes place, that it's not going to shift on the fence. You want to make sure that it's still going to be tight against the fence, otherwise it could bind. Okay, so I'm going to cut this portion of the board off at the radial arm saw. Give me just a moment to swing over. I'm not going to use this saw. I'm going to use the one that's over here a little bit further. Okay, I've got it set up here at the radial arm saw. This portion of the board is going to be against the fence. So it'll still be against the fence after this cut is made. This is coming away from the fence right here. And so I would not want to push on this side, because then that'll leave this side away from the fence, and that'll be dangerous at the radial arm saw. So I want to make sure that I've got it flat against the fence. And because I've got it set up this way, I'm going to have to pull the radial arm saw out, not using my right hand, but using my left hand, and hold the board using my right hand. Here we go. Yeah, I've got a Forest Chop Master. Okay, so let's talk a little bit more about radial arm saws, and then we'll get into the specifics of this saw. One of the areas that radial arm saws excel at is the use of dado stacks for making various cuts, such as tenons for mortise and tenon joints. This is a portion of a Forest 8-inch dado stack, and I also have next to it a Freud dowel width dado stack. You want to make sure that your dado stack also has a negative hook angle for its teeth, just like the saw blade that you run on the saw. I've found that this Forest dado stack is a little bit likely to self-feed. Trying to pull the saw through the cut, it tries to self-feed when I'm using this Forest dado stack. I just checked it, and these chippers are in fact angled backwards, so that they do have a negative hook angle. And I also checked the Freud, and this has a negative hook angle on the teeth as well. So this would probably be safe on a radial arm saw as well. So that one of the big advantages here of a radial arm saw over a sliding compound miter saw is that you can use one of these dado stacks, cutting 3/4 of an inch wide on a radial arm saw, but you cannot do that on a sliding compound miter saw. With a radial arm saw, also, you saw that you keep the blade to the back until you need to use it, and then you pull it forward to make your cut. Whereas on a sliding compound miter saw, what you do is you actually have to pull the blade out towards you, drop it down, and then sometimes nurse the blade back and forth to saw through the stock, and then you make your cut going backwards toward the fence. So it's a more complicated movement compared with a radial arm saw. So in some ways, this could be a safer operation to pull it forward. But once again, the disadvantage of doing that is that you're making a climb cut. But it's not safe to always have this blade out right here and have a board back here and make your cut going this way with a radial arm saw. That is definitely not a safe cut. So you never want to do that. So Dado stacks are quite helpful on a radial arm saw for various cuts that you can't do easily on a table saw. Once again, you don't move the stock on a radial arm saw, and so that takes out a lot of the burden of trying to keep the cut straight when you're cutting the board. Okay, speaking of cutting boards, these are examples of some of the boards I used to cut on my radial arm saw 30 plus years ago, and these would go into an English garden bench that I would make. And the saw that I had at the time, which was a Craftsman radial arm saw, it was accurate enough that I was able to use that saw to cut these to length, one after another, and these would get stacked up essentially end to end roughly 16 times, and over that distance I was almost always within a 1/16 of an inch of tolerance. In other words, over 16 of these I was off a total of 1/16 of an inch, and I used the dial indicator or digital caliper to make sure that these boards are coming out at the right length. And the unfortunate thing is that these boards are so small, if you were to try to cut that, you'd have to have your finger right there next to where the blade is at. And that's definitely not a safe operation. So what you'd want to do instead is to have a sacrificial push stick that you could use. And I would actually probably cut 6 or 8 of these at a time, just like so, with 6 or 8 sticks going across, and then I would hold them all in place just like that as I pulled the saw out and through the cut. And obviously I'd have to be careful that that didn't happen, so I'd probably have to hold it downward like that, and I can make the cut. And then after I get this lot done, I can move it out of the way and then shift the boards over and do the next batch. And then I would hold that down, pull out the blade, make the cut, and keep on repeating until I have a full bag of these that I could then use to build many benches. So don't be shy at using push sticks on a radial arm saw to keep your finger away. I always like to keep my fingers at least 4 inches away from any spinning blade, just in case something happens that causes the board to shift. That 4 inch of tolerance gives me a little bit of time to move my hand out of the way if something goes wrong. Okay, another thing to mention is that the fence that's mounted into the radial arm saw is considered to be sacrificial. In other words, you're going to be cutting into this fence, especially as you're using different bevel angles and you're tilting at different angles for different miter cuts. This fence is going to get tore up. Don't be too concerned about that. You can always replace the fence fairly cheaply. However, you do need to make sure that when you replace the fence, that you put a straight board into here and not just use any plain sawn board. This is a vertical sawn piece of Douglas fir that's quite old, and so I was pretty certain that it was going to be flat. On my other 12-inch radial arm saw, I used a piece of very old flat sawn Douglas fir. And the unfortunate thing is that that piece was slightly warped out in this section here. And so when I was tuning up the saw to set it to 90 degrees, I had the square set in here to get a square cut, which meant that every time I was pushing the board up against the fence on this side, I was getting a square cut on the end of the board. However, because this end of the board had a slight warpage to it, if I held the board against the fence using my left hand and pulled the saw out using my right hand, I would actually end up with a cut that was slightly out of square. I fixed that on the other saw, but I have not yet aligned the blade so that it runs 90 degrees on both sides. Right now, if I pull it out, it's going to be off by about a 32nd of an inch at the full extent of the blade. And so I've got to fix that, and I've got directions printed out from the manual that I found on the internet that tell me how to make that adjustment. And so I'll be doing that in the next couple days to get that straightened out. Okay, before digging into the details on this saw, let's try to make another cut. I have a piece of cherry here that's been surfaced on 3 sides, and so I've got a straight edge back here and also a straight face on both sides. But this edge right here has not been cleaned up yet on the table saw, so I can't put this edge against the fence, but I should be able to put the other edge against the fence and it should be straight. Now what I want to do here is I want to cut off this end section right here because I've got a little bit of bug damage right down here. And so what I'm going to do is I'm going to hold this against the fence using my left hand just as normal. I have the opposite end resting on the chop saw, so it's well supported at the other end. I don't have any problems with support on this end because I've got plenty of table space here left. And so I'll go ahead and make the cut now. Okay, you may have noticed that I did not stiff arm the cut. In other words, I didn't have my arm extended out quite as tightly as I probably should have. And that's because I know that this negative hook angle on this blade is much less likely to grab. If I had tried that with the original saw blade that was on the saw, this thing would have tried to pull out and self-feed itself across the board, but it didn't do that with this blade that I've got mounted onto there. Okay, so let's take a look at the cut. Here you can see that the cutoff piece is extremely smooth. There's no chip out anywhere on that board. That's the type of quality that you can expect from this type of a saw, especially from a turret style saw like this saw. Okay, so I just tilted the camera up now so that you can see that in fact this is a turret style saw. And what that means is that if I were to pull this blade out and I were to rotate this at an angle, what's going to happen here is that instead of the arm pivoting from way back in the back here, it actually pivots in the center. And what that means is that this tilts right here, and so I've got plenty of support on both the left side of the blade and also the right side of the blade if I were to do a miter cut. Regular radial arm saws do not have that ability. A regular radial arm saw would actually have the pivot point way back here in the back, and so if you're wanting to do a miter cut at 45 degrees, the saw is going to actually come out over in this area here instead of being here in the center, so that you wouldn't actually have any support on the left side if you were to attempt a cut on the left side at a 45 degree miter. You wouldn't have that problem with this saw. And this saw, which is a turret style once again, is much more stable than one that pivots at the back. In other words, it's less likely to get shifted out of place as you're making a cut. It's less likely to tilt ever so slightly during the cut because, once again, the pivot point is right here in the center of the table instead of being a couple feet or at least 1.5 feet behind where you're cutting. And so the turret style saws are in higher demand typically than those types of saws that only have a straight arm that come out. And we'll take a look at those types of saws later. I've got 2 of those style saws in my shop. But one of the advantages, once again, of the turret style is that you have plenty of support on the table. However, the tables on these types of saws are kind of small in comparison with the other style saws because they don't need to be nearly as large. So that means that you can squeeze one of these turret style saws into a smaller area. And just because it's a Delta turret style saw does not mean that it's necessarily a 12-inch or larger radial arm saw. Delta made a 9-inch version of a radial arm saw that was a turret style also. I believe that was a model 900. And so you would probably not want to get one of those because that's going to be limited on capacity. And give me just a moment to turn off this phase converter so that we don't have a background humming noise. And one of the other nice things about this Delta 12-inch saw is that it has a 5/8" arbor, just like most regular table saws in the 10-inch and smaller range. It has a 5/8" arbor, but the issue that you're going to run into when you try to get blades is that most of the 12-inch blades will have a 1-inch arbor hole in the center. And so this has a bushing that goes into the center of it. Freud makes pretty good bushings. As a matter of fact, I use a Freud bushing in the center of the blade that's mounted into the saw. I'm not sure what brand of bushing the previous owner used, but it looks like it's reasonably flat. There are cheap Chinese bushings that you can put into saw blades also, but I wouldn't risk one of their bushings to be true. You'd want to make sure that you get one that's from a high quality manufacturer so that you know that it's flat and it's not going to cause the blade to wobble at all for a good quality cut. So because this saw is a 12-inch and it also has a 5/8" arbor, that means that you're able to use your 8-inch stacked dado that you already have for your table saw. You can use that in this radial arm saw. A stacked dado set with a 1-inch arbor would be quite a bit more expensive than an 8-inch stacked dado set with a 5/8" arbor. So that's another advantage of going with this particular 12-inch radial arm saw, is that you can use the stacked dado set that you probably already have. As long as it doesn't have a positive hook angle. You'd want to stay away from those types of stacked dados with a radial arm saw. So let's take a closer look at this saw. I'm going to give you some dimensions of the standard table surface, which is what's still on this saw. I'm not quite sure how old the saw is, but I'm assuming that the company that bought it had only recently acquired it just before the company went out of business, because it's in such good condition in terms of the table surface compared with the other radial arm saw that I got at the same auction. In that radial arm saw, whoever was using the saw actually cut all the way through the table surface. Okay, so the standard table on this measures roughly 30 inches. It's actually a 32nd of an inch over, so it's 30 and 1/32 of an inch in length. You'll probably find that other style radial arm saws, the non-turret style that have a pivot point at the back, they're going to have a table that probably measures at least 44 inches across. If you buy one of these saws and it does not have a table on it, I'd recommend that you actually make the tabletop larger than the standard dimension of just over 30 inches. you'll be much happier with the support that it offers. And as you can see here, what I've done, because this one board that was back here for the table was missing, what I did was I actually replaced that with a piece of vertical grain Douglas fir, and this board measures a total of 66 inches in length. So roughly half of it, or more specifically 29.5 inches of it, is to the left of the blade, and 36.5 inches of it is to the right of the blade. And that offers a lot of support for any boards that are cut on here. You may not want to make the entire surface that large if you're replacing the table that was on your saw, but you may want to make it larger than the stock size. I would say by at least 6 inches on each side, if not a foot on each side. And if you go a foot on each side, then you're going to end up at roughly 54 inches for the tabletop. Okay, this tabletop has multiple sections in it, which allows you to set up the saw for a maximum crosscut capacity whenever you need it. And by moving this board right here, which is kind of narrow, it measures 1.5 inches in width, you can move this board behind the fence, and that'll gain you an additional 1.5 inches of crosscut capacity. The problem with doing that is that that'll actually push this blade forward 1.5 inches, roughly to that point right there. And as you can see right there, now the top of the blade is coming out over the fence. And so you cannot have a very thick board there. You may be able to get away with maybe 1.25 inches without having any issues. But then that would give you a longer crosscut capacity. Right now I've got 13.5 inches, so if I were to add on another 1.5 inches to that, that would bring me out to 15 inches of crosscut capacity if I move this 1.5 inch wide board behind the fence. But then I've got to be more careful to watch where that blade is at so that I don't have a board touching that when I turn on the saw. Okay, so the main table board here, in case you need to recreate this table, measures 14 3/8 inches wide. The next board measures 1.5 inches wide. The next board after that measures 2 3/4 inches, at least on this saw. Another saw that I've got back here, which is a single phase, I actually made that board 3 inches wide, which was probably a mistake. It should probably be 2 3/4, just like this one. If you make it 3 inches wide, that's going to push this fence back another 1/4 inch, which means that you may gain a little bit of crosscut capacity, or you may not. It all depends on how things work out. Okay, so this board should either be 2 3/4 inches or 3 inches across, as this one here. And then behind the fence, there's another board that measures roughly just a hair over 2 7/8 wide. And then the next board behind it measures 3 inches almost 4 inches across. It's about a 32nd under 4 inches. So 3 inches and 31/32 across, roughly. And you don't have to have them exact, but you do want to make sure that they're reasonably close. And if you've got to replace this main board here, there's a locator pin that goes in here, and also another locator pin that goes at the opposite end. You got to make sure that you drill those holes out for the locator pins very accurately. You've got a hole that's here for a bolt, another hole here, another one here, and another one here. These exact positions may be in metric or maybe not. I've got, it looks like for this front bolt location, it's about 4 1/4 inches to the center. And the next one here, it looks like it's about 10 1/4 inches. And they should be in the same locations here. And they are inward. It looks like it's about 5 3/8 of an inch to the center of where you've got to have that hole. And it looks like it's the same here. For this pin, that pin looks like it's 5 5/16 from the end. And then in this other direction here, it looks like it's about 7 3/8 from the front of the table. Okay, so that may help you out. And you may notice in the back here that I've done something to try to collect some of the sawdust that comes out of the saw. This is a brush that you might use on a CNC machine to collect dust, and I cut it down so that it fits onto this board. And I just created a little assembly here that fits right down into the pocket at the back of the table. Now, I don't yet have dust collection over on this side of the shop, but that should be happening at some point here in the next decade or so. And so I'll be ready for it with this box that I've got mounted on there. And so that just fits right back down into the back end of the table. And then what I'll do is I'll create a box underneath the table here, and then I'll mount this dust collection port onto that box. And then I should be able to collect all the sawdust that's generated at the saw as long as I keep it at 90 degrees. Now, 30 years ago, I was using a Craftsman radial arm saw, and for that one I was having to make all sorts of different bevel cuts and miter cuts for the projects that I was working on at that time. And so I actually had a box that extended all the way across the back of the radial arm saw, and it had a curved surface to cause all the chips that come in to be deflected and then fall down into the box. I have a similar design in this box, in that there's actually a curved surface right up in here that directs the chips downward. And that's why there's a little pocket here, and that causes a little bit of a swirling motion, hopefully, that causes the chips to fall downward instead of being bounced back out. The one problem that I had with this radial arm saw is that it was too short. The table on it wasn't far enough off the ground to make it comfortable to use. When I had a dado stack mounted onto here, what I was having to do is to tilt my head way down to be able to see where the dado stack would be cutting. And that obviously is not safe. So I've raised this table up using a platform at the bottom. So I've got this so that the tabletop is 37 3/8 of an inch off the floor. And so that puts us at a comfortable working height. And the height here is also identical at the miter saw. And it's identical at the other radial arm saw, which is just to my right. I'll pan the camera down and you can take a look at the structure that I created underneath the radial arm saw to raise it up. Radial arm saws are sitting on a platform that raises the table an additional 4 3/4 inches off the floor for a more comfortable work height. Mortise and tenon joints are used to join the stretcher to the long supports that run from the front legs to the back legs. They're topped by a 1/2 inch thick piece of oak, and then the bottom portion is a laminated section of pine that was used. I used the oak so that the legs did not sink into the wood. Underneath these long boards are carriage bolts at each corner that allow leveling the tabletop to other surfaces in the shop, so that each of these radial arm saw tables are at exactly the same height and they're level with each other, so that one table on one radial arm saw is able to support boards for another table. In addition, the chop saw, which is nearby, is also at the same height, allowing, again, one saw to support another saw. Hey, this is a 3-phase version of the saw that was featured on the New Yankee Workshop that Norm Abram had on PBS years and years ago. This saw originally had a list price in the early 2000s of just over $4,000. It may have actually been a couple $100 over that for a list price. However, it was selling on Amazon for right around $2,500 new, although every once in a while the price would jet upwards around $3,100. I picked this saw up at a business closer auction, and the bidding had this saw and a 10-inch Delta Professional saw. The bidding was going on at the same time for both of the saws, where you could pick your choice, whoever was the winning bidder. So I bid the saw up to $250, and I won the bid. And so, because I didn't have 3-phase power yet in the shop, and this was the saw that I really had my heart into getting, the turret style Delta, I bought this saw knowing that I would eventually be able to use it. And then I also bought the 10-inch Delta Professional saw, each of those for $250, plus I believe it was a 15% buyer's premium, and then state sales tax. So the saws came out to be a little over $300 each, with taxes and the buyer's premium included. That was a very good deal for a saw that was selling on Amazon for right around $2,500. Today, you would be able to pick these up for probably roughly in that same price range, if not cheaper. Now, 3-phase saws are not too terribly popular because you've got to have a 3-phase converter to run these saws. I have a 5 horsepower rotary phase converter that I use, and I had to run a number 8 wire, which you can see possibly back here behind the saw, to power that 5 horsepower phase converter. And that number 8 wire was quite expensive to purchase. So There's also single-phase versions of the saw that you'll be able to find on Facebook Marketplace and Craigslist and various auctions, such as business closure auctions or estate auctions. So you may be able to find one of those. As a matter of fact, a YouTuber that I've been following recently picked up a single-phase version of the saw that was still on the shipping crate. The motor was still wrapped in cardboard, and he paid $350 for that saw. So he got a killer deal on that saw. He'll have to probably build a table for it. But other than that, he's got essentially a saw that would sell for over $4,000 new today, even though it was manufactured in 1992. Well, radial arm saws are not quite as popular as they once were. Once again, the sliding compound miter saws have kind of taken over the market because they take up a smaller footprint than most radial arm saws, even though they don't do nearly as good of a quality cut as a good radial arm saw like this one. On this saw, all the controls to adjust it are in the front of the saw or on the side of the saw, so they're all in close proximity. You can't see the knobs here to adjust the miter and the bevel cut on it, but you've also got a crank handle that's down here that's just off camera that's up front, and so that makes it really convenient. There's also lock knobs on the front here for locking the table into position. That's one of the nice features of this Delta 12-inch saw that you won't find on the 10-inch Delta professional saw. It has all of the knobs and adjustments at the back of the arm, which is not terribly convenient, or for the bevel that's probably on the motor, so that wouldn't be quite so bad. But for the miter cuts, that is on the back of the arm, and so that they may be a little bit challenging for you to reach back and make adjustments. Okay, so let's move the camera over and we'll take a look at a single phase version of the saw. The single phase version is a model 33-890. This saw is the single phase version of the three-phase saw we just looked at. This is set up essentially the same way as a three-phase saw, although this table board is not quite as long as it is on the three-phase saw. This table has been through quite a bit of damage over the years. It was exposed to a lot of moisture in the environment, and so the MDF top on this has increased in height from an inch to about 1 1/16. And people over the years have tried to patch holes or saw blade cuts in the tabletop, and they've done a terrible job at it, really. And I wish that they had used the sacrificial 1/4-inch MDF top on this to make it so that there's less saw marks in it. But through here you can see where they had the saw blade at a 45-degree miter cut. You can see a little bit of a white line here where they tried to fill it in with some sort of wood putty. This surface here is not real flat because they had tried to fill this area in also. And so right now, this fence was not entirely flat. This area out in here was slightly kicked outward. And so I've straightened this out on the jointer so that it's now flat. But unfortunately, because I had calibrated the saw using a framing square on this area here, now that I've fixed the fence, the saw blade, when it's pulled forward, it's now off by roughly a 32nd of an inch out here at the front of the table. So I'll need to adjust this sometime here in the near future so that it's back to cutting at 90 degrees square on both the right side of the blade and also the left side of the blade. Previously, it would cut square on the right side of the blade, but not on the left side. And it took me a while to figure out exactly what was going on, and that it was a problem with this fence. And as you can see here, this is a flat sawn figure on this board. This board was originally a bleacher in a high school gymnasium back in the 1960s. And then they eventually replaced those wooden bleachers with plastic, and I ended up with a couple boards from that retrofit. Okay, so this saw behaves much the same as the other saw. However, the bearings in this saw are in rough shape. I'll power it on here so that you can hear it. And you can kind of hear it as the blade is spinning down. There's a little bit of vibration. And I just did something that I should not have done. I took my hand off the handle. You never want to do that while the saw is on. You always want to have one hand holding the board or using a push stick to hold the board, and have your other hand on the saw, just in case this saw blade somehow engages wood and it pulls itself through the cut. You don't want to have that happen. Once again, this saw is essentially identical to the three-phase. However, the motor on this saw was manufactured by Emerson, and the motor on the three-phase saw was manufactured by Marathon. As such, this saw has about an extra half-inch of cutting capacity underneath the motor than does the three-phase saw. And so that's a nice feature. On a 10-inch saw, you could possibly cross-cut a 4x6 if you first cut it in half, and then you could clean up the cut just by having the 4x6 out here on this area. With this saw, you don't have that problem. You can just simply cross-cut a 4x6 or a 4x8 or even something a little bit thicker than that without any issues. So with that 10-inch saw that I used to cross-cut 4x6s with, the 4x6 would not fit underneath the motor. And so that's why I would have to raise the blade up, make a cut, flip the board over, make another cut, and then I could put the board out here, drop the blade back down, and then make a cleanup cut across the board. Here I can just make a single cut to go across, and it cuts the 4x6 post. So that's a nice feature of this saw. One of the limitations that I learned about this saw is that when you've got an 8-inch stacked dado blade mounted onto it, you're not able to create a half-lap joint in a 3/4 inch thick board. I tried doing that on this saw, and because there's a little bit of surface rust on the column in the back here, I thought that it was reaching a point when I was adjusting the blade height to bring it down. I was getting quite a bit of resistance with that 8-inch stacked dado mounted onto the saw. And I thought, okay, well, it's just a little bit of rust. I'll keep trying to push it to make it go down. Well, that was a big mistake. And I found out that these 12-inch Delta saws, they have a nylon or plastic gears. As a matter of fact, there's 2 of them on the underside of the saw. And if you put too much pressure on them, they will snap, just like this one. This was one of the 2 gears that was underneath the table, and the 2 of them are identical to each other. It's a little bit challenging to swap these out. I did find a company on the internet that still sells these gears, fortunately. And so when this one snapped, I bought 2 gears from the company to save on shipping costs of each individual one in case I have this problem again where I forget that I can't bring the blade down with an 8-inch stacked dado so that it's within 3/8 of an inch of the table. I can only get it down to somewhere between a 1/2 inch and 5/8 of an inch before there's a lot of pressure put on these gears. And I'm sure that Delta designed these gears so that these would break, and it's a $20 replacement or a $50 replacement, whatever they cost, rather than stripping out a metal gear that may be impossible to replace, especially with the way things are right now with Delta being owned by a Chinese company, and they've totally forgotten their heritage of the original Delta company, where they don't support their old machines. So this is a little plastic gear. I can insert some notes on how to replace this gear. I typed up some lengthy notes, and I never did anything with those notes. And so I might as well include that in this video in case you need to replace the gear. And there are 2 of them once again. Unfortunately, only one of them snapped on this saw. Here, I'm probably going to have to replace this top surface because it's in pretty bad shape. And when I do that, I'll probably add a 1/4 inch MDF sacrificial top to it. Okay, so let's go back and we'll take a look at the 10-inch Delta Professional saw. This is a Delta 10-inch 33/830 professional radial arm saw. When I bought this at the auction with the 3-phase radial arm saw, the table that was on it actually was cut all the way through in the center, right where the saw comes through. And so that table had to be scrapped. And it looked as though they had already replaced that table at least once, and they only bothered to attach a small section of a new table onto the saw. So I didn't have any of the dimensions for that saw table to recreate it. In addition, the original table that was on that saw was made up of 3/4 inch particle board rather than 1-inch MDF as is used on the 12-inch Delta saws. And so when I built this table, I built it by laminating 2 1/2-inch sheets of MDF face to face, and that worked out to eliminate any warpage in the MDF. I had it set on top of my table saw, and I had concrete blocks on it weighing it down to make sure that it was flat, and it would be glued flat. And then on top of that, I put 1/4 inch MDF so that if I need to make miter cuts or bevel cuts on this saw, I don't ruin the 1-inch MDF table that I created underneath. I can just replace the sacrificial 1/4 inch MDF cheaply, and then I'll have a 0 clearance underneath the saw kerf. Okay, this saw pivots at the back of the column rather than the turret style Delta, which pivoted here in the center. And what that means is that this arm is going to be more likely to shift ever so slightly during a cut if you're not holding on to the handle firmly when you're dragging it through the cut. Now I've tightened this up quite a bit so that there's almost no deflection. However, I can still deflect this blade roughly a 32nd of an inch side to side, whereas I couldn't deflect that 12-inch saw at all side to side by grabbing onto the handle. And of course, I mentioned that the Bosch sliding compound miter saw that I looked at an auction, which was essentially new, that I was able to shift 3/16 of an inch side to side. And so this is still much more robust than a sliding compound miter saw, although I wouldn't recommend a Delta 10-inch saw. This entire saw was not manufactured by Delta. Instead, it was manufactured by Emerson. Emerson also manufactured the majority of the Craftsman radial arm saws, as well as the rigid radial arm saws. This may be to tighter tolerances than the Craftsman radial arm saws were manufactured to, but maybe not. This saw has a somewhat small motor on it. This saw has a 13 amp motor on it, which Craftsman will claim that a 13 amp motor is 2.75 horsepower. And it's nowhere near that amount of horsepower. 13 amps is probably just a hair less than 1.5 horsepower for induction style motors, which is what this is. The two 12-inch Delta saws that we looked at earlier both have 1.5 horsepower motors, but those run on 240 volts. In one case, it's 240 volts, three-phase. And those draw a bit more than 13 amps. I believe they're up around 15 or 16 amps at if they were running on 120, or roughly 7.5 or 8 amps on 240. Okay, one of the unfortunate things about this saw is that it does not have a good 90 stop for the miter. And when I was setting it up for the new table, I was ever so slightly off the 90-degree stop up here. And so what that means is that when I adjusted the 90-degree stop, it actually ends up coming out a 1/16 of an inch out of square in 16 inches of cut. So if you were to do a calculation on that, it's off by 0.224 degrees at full extension. Now you may not notice that if you're only cutting narrow boards, but if you're trying to cut down a sheet of plywood, such as a 28-inch wide sheet of plywood, you cut it once and then you flip the board over and you cut it a second time, that 1/16 of an inch off is going to show up in the end product. And so I've already cut the zero clearance cut into the table, and what that means is that I'm kind of out of luck here. I could replace the sacrificial top once I straighten out the 90-degree angle. There's a rather lengthy instructions here from the manual that I found online for adjusting that. I'll be going through those steps here in the next couple of days to see if I can get this straightened out. Okay, so this has pretty much all the adjustments, including the height adjustment, the angle of cut, and various other adjustments in the back. They're not nearly as convenient as on the 12-inch saw. Hey, let's plug this in, and we'll try a test cut with it. Okay, it looks like it is already plugged in. It worked its way out of the electrical outlet ever so slightly. I have another piece of black walnut here. This is surfaced on two sides, so it doesn't have a jointed edge. And I have a little bit of waste here that I can get rid of. Unfortunately, I've got other things in the shop right now that don't belong in a woodworking shop, so I can't position the board going in this direction so that I can hold on to it with my left hand while I draw the saw with my right hand. So I've got to position it this way, and then I can hold this against the fence. And I'm looking at this, and I've got good support up to about here, where it's not going to try to feed itself backward once the cut's made. If I were to flip this over, and that also looks reasonably close to being straight, but we'll do it this way here so that we can see what needs to be cut off. Okay, now I would normally wear hearing protection when I'm using a radial arm saw, but I'm not going to do it in this situation. The switch to turn on the saw is down here, just above the handle. I'll have to hold this using my right hand and pull it out using my left hand, which we had to do on the 12-inch saw. There you can see that the blade is almost protruding out from the fence. Okay, so we'll turn on the saw and we'll make a cut. The bearings in this still sound like they're in good shape. You'll notice that the saw did not try to pull itself through the cut, and that's because I've got another Forest Chopmaster blade on here, in this case a 10-inch saw blade. And let's take a look at the quality of the cut. As you can see there, it's almost chip-free. There's a couple little spots here with a little bit of chip out, but it's not so bad. It is a nice quality cut, but of course it's not a square cut because the saw is off by a 1/16 of an inch here at the end of the cut. So it may only be off by maybe a 1/64 of an inch back here, but it's still off a little bit. And of course, small errors, if you've got enough of them, they'll add up to a pretty big error. Okay, so this saw, much like the 12-inch saws, can be positioned in different ways. You can do rip cuts on it, although I wouldn't recommend it. You can do cross cuts at 90 degrees. You can also set it up so that it's coming out at an angle for a miter cut. You would have plenty of space here on the right side of the blade for that to happen. But if you were to rotate this blade to this other side to make a 45-degree cut, you'd be off the table. So you wouldn't have any support on that side. And so that would be potentially a dangerous cut. You would want to use some sort of a digital readout for measuring the angle of the blade. This has just a pointer that points at a bevel gauge on it, and the gauge for the miter is actually at the back of the column here. And so that, once again, is just a metal pointer. So you could be off by a half degree or a degree and you wouldn't even know it, potentially, when you're looking at that. So you'd want to use some sort of a digital gauge to double check the bevel and also the miter. We used to have a device that looks like this mounted onto it. The 12-inch 3-phase saw also had one of these, and this would cause the saw motor to retract if somebody leaves it out like this and they let go of the handle. This device right here would try to pull the blade back so that it's behind the fence. And that's a safety measure that that this saw had on it because it was required by OSHA. Now these particular devices were not mounted on to neither of the saws in a very good way, and so I've removed them because they were causing more harm than they were doing good. I don't need to be OSHA compliant here in my shop, but it would be nice to have some sort of an automatic return like what these offered on these saws, just to make them a little bit more safe so that I don't leave the blade out from the fence as it is right now, that it would automatically retract. Now I didn't have the dimensions for what this top should be. I did find through quite a bit of digging on the internet that its tabletop is supposed to be 44 inches wide, which is quite similar to the Craftsman table. And in total, from front to back, it measures 27 inches. This front table board measures 19 3/16. There's a small board between the large board here and the table fence, and that board measures 1 5/16. And then there's a board in the back here, and that board measures 5 3/4 inches. So if somebody's trying to recreate the original tabletop for a Delta 10-inch professional saw, you can use those dimensions to set it up. So let's go take a look at my 10-inch Craftsman radial arm saw that I bought in 1990. This radial arm saw is the top of the line Sears Craftsman radial arm saw from the late 1980s or early 1990s. I acquired this in 1990. Found it in a newspaper classified ad, and this was the top of the line model for the 10-inch saws at the time. It has 6 drawers underneath, and it has a very nice working height. One of the things that I really like about the saw is that all the controls for it are up front. There's an elevation crank that's down low here. Unfortunately, that broke off probably about 25 years ago when this saw was being stored by a friend. It also has controls up front here for swinging the saw to 45-degree miters, and it has a nice positive stop. And it also has a digital readout here that tells you how high the blade is off the table. It'll tell you the bevel angle within about 1/2 of a degree, if I recall correctly. And it also has some other functionality built into the digital readout as well, such as telling you the miter angle and things of that sort. One of the defects of the saw is that it has some cheap components in critical places. This is the motor mount for the saw. This part fits up into the area right up in here. And this is what attaches the saw motor to the arm. Unfortunately, the part snapped, not once, but twice. It snapped on me in the early 1990s, early to mid 1990s, and then a second time in the early 2000s. Yet here you can see that there's a hairline fracture that runs from this spot right down in here all the way across and around, and so it's still broken. And I replaced this part the first time it broke in the early 1990s, and I bought replacement parts for it the second time it broke in the early 2000s, but I never actually installed the parts to fix the saw. I felt that at that point the saw was too dangerous to use. I had a 3/4 inch wide dado stack mounted in the radial arm saw at the time that it snapped. Actually, I believe it happened both times that it snapped. And so I was pulling the dado head stack out, and then all of a sudden the motor just dropped. And that's kind of a very dangerous situation. And so I stopped using this saw, and I started looking around for other saws that would be a suitable replacement for this saw. This saw has some very nice features, and one of those features is that it's got a tall table. This table is about 37 inches off the floor, and so that makes for a very nice, comfortable work height, especially when you have a dado stack mounted in the saw. It has a width of 44 inches from side to side, and as you can see here, when I built the fence, I had the fence extend out roughly a foot on each side so that I had the ability to clamp boards to the fence for setting the length of cut. Front to back, it has a dimension of almost 28 inches, and so it has a nice large work surface. It has controls in convenient locations, and the blade that I had mounted into it at the time that I was using it was a Sears Craftsman blade. I believe it had 80 teeth, and unfortunately this blade does not have what's called a negative hook angle. In other words, the teeth are tilted forward, similar to how ripped teeth are angled forward for aggressive cuts. And what that means is that when you're using the saw, because it's doing essentially what's called a climb cut, it's trying to actually self-feed itself through the board that you're cutting. And with the non-negative hook angle of the blade, so it would try to grab onto the board, and then it would try to forcefully pull the saw motor forward toward you. And so you have to make sure that you've got your hand well out of the area where the cut is going to be taking place, otherwise you'll end up losing a finger. And so that's one of the problems that these radial arm saws have, is that if you don't know how to get them set up correctly with the right type of blade, that can be quite dangerous, even when you're only using them for crosscuts. The 10-inch Craftsman radial arm saw was a very nice saw. It was actually built by Emerson. In the late 1990s or early 2000s, Emerson had a recall on the saws that it produced for Sears Craftsman, where they would give you a brand new tabletop and also retrofit a much safer blade guard on the saw. And unfortunately, I didn't take advantage of that offer. And then once that offer ran out, they were offering people $100 to simply destroy the saws. Emerson also made saws for Rigid and Delta. It did hold its tolerances very well when I was using it in the 1990s. I could rely on it to make repeated cuts at the same dimension over and over again. So that was nice, but of course now you can see that the whole head moves because that motor mount, this part here, is damaged up inside. This saw has a very large table on it, which is nice. The unfortunate thing is that the design of this style radial arm saw that has a pivot point at the back is that when you use the miter feature to bring it over to the left, you can't really use it to miter 45 degrees at the left, because 45 degrees is somewhere out in this area here, and you're essentially off the table. So this portion of the table to the left of the normal saw travel is completely useless when you're trying to do a 45 degree miter on this side of the table. On the other side of the table, you've got a little bit of room, but not a whole lot. As you can see here, it's almost off the table over here as well. That's a problem with this style of saw. That's all for today. Thanks for watching. Bye.